Welcome back, everybody. Wanted to take a minute tonight and just record this video after assembling it and putting together and doing a bunch of research. I had a question in the comments on my supernova video about kilonova, and I think the kilonova, especially with what's happened in December of this last year in 2025, it's worth having its own video about. So this video, kilonova, what are they? Why are they so interesting? I could add, what are they still teaching us? You can see here, this is just an artist's rendering of two neutral stars colliding to form a kilonova. And let's just get this out of the way, what a kilonova is. It's a cosmic event that is rare, and it's the result of the merger of two neutron stars that are in orbit around each other, or the merger of a neutron star with a black hole. And that event results in a kilonova. You can see here the image of two neutron stars colliding by an artist's image. It's kind of fascinating to look back at how quickly our understanding of the universe can shift. For decades, the kilonova was little more than a mathematical curiosity. Today, it's one of the most exciting frontiers in astrophysics for many. The story starts about 28 years ago in 1998, when astronomers Lee and Paskafisky first suggested that when two neutron stars collide, they shouldn't just vanish, they should trigger a fleeting thermal flash. At that time, they were dubbed mini supernova because they were predicted to be about 1/10 to 1/100th the brightness of a typical supernova explosion, a type 2b. It wasn't until 2010 that Brian Metzger coined the term kilonova, noting that while they were smaller than supernova, they were still 1,000 times brighter than the classical nova. We'll talk about a classical nova in another video coming up. Detective work, there's always, that's what I love about astronomy. It's really, my wife loves mysteries. Astronomy is just one big mystery after another. It's just detective work. It's getting in and using your brain and getting in and finding hypotheses and then solutions and evidence to back that. The hunt for a definitive observation was a true detective story. We had a few maybe moments when GRB 080503 in 2008 and GRB 130603b in 2013, but the slam dunk finally arrived. Those really couldn't be confirmed to be kilonovas. But the slam dunk arrived on October 16th, 2017. That was the historic GW 170817 event. For the first time, the LIGO heard the gravitational waves, and telescopes like Hubble and ESO saw the bright light in the nearby galaxy NGC 4993. Here you can see 4993, and Hubble was able to image it, and basically they discovered it. They found the gravitational waves, and within 6 days after finding it, the light faded, as you can see here, going from August 22nd, when they first imaged it, all the way to the 28th. It really began to dim. So a kilonova will fade a lot faster than most novas, definitely a lot faster than any supernova. Again, a supernova type 1a, high brightness and then quick and rapid loss of light, but still pretty bright for a while. A type 2, very bright, and then gradual depending on the type it is, right? We went through the light curves on that. Anyway, but why did they glow? One of the things about these, when they merge, they glow. The secret lies in a process called rapid neutron capture, or the R process. In the violent aftermath of the merger, a sea of neutrons bombards iron atoms so quickly that they transform them into heavy elements like gold and platinum and uranium. A fun fact is that 1 kilonova will produce more gold than the mass of the Earth. It's literally cosmic alchemy. The radioactive decay of these newly forged elements is exactly what creates the infrared glow that we observe. Right now, we estimate that the kilonovas are rare. We've only confirmed in one, and that is GW 170817 from 2017. Some astronomers estimate there's probably only about 10 such candidates in our entire galaxy. What's the future of these? Well, now we got a new term, superkilonova. Just when we thought we had begun to figure out kilonova, the universe surprised us again, threw us a curveball. Recent discoveries like GRB 211-211A have shown that these mergers can last much longer than 2 seconds, and that challenges our old definitions. On August 18, 2025, the LIGO and Virgo detectors picked up a signal, S250818K, coming from a source about 1.3 billion light years away. It looked like a standard neutron star merger, but the data told a much stranger story. According to the LIGO Virgo KGOR team, the combined mass of these two objects was only about 0.87 solar masses. To put that in perspective, our standard models of stellar evolution say that a neutron star shouldn't be lighter than about 1.2 times the mass of our sun. Yet, there is a 99% certainty that one of these stars was a featherweight, weighing in at less than 1 solar mass, and it shouldn't have happened. As soon as the alert for S250818K went out, it was all hands on deck for the global observing community. Just a few hours later, the Zwicky Transit Facility, STF, and the Palomar spotted something, a rapidly fading red object right where the gravitational waves originated. It was designated AT2025ULZ, and in this image you can zoom in on it, you can enlarge it, whatever. You'll see the core of the galaxy, of the host galaxy, and just down and below to the right there you'll see AT2025ULZ. For the first 72 hours it was a textbook discovery. The deep ruby red glow was exactly what we looked for, a signal of heavy elements like gold and platinum, uranium being forged. Everyone thought we had our second ever definitive kilonova. But on the fourth day, the object did something truly bizarre. It started to brighten and turn blue. Follow-up data from the Keck Observatory in Hawaii revealed signatures of hydrogen and helium. This is the calling card of a Type 2b stripped envelope supernova, an explosion where a massive star sheds its outer layers to a companion before going boom. This created a real divide in the astronomical community. Many astronomers dismissed it as a coincidence, arguing that a standard supernova shouldn't produce the gravitational waves we heard earlier. But as Mans Colossi noted, while some lost interest when it started looking like a supernova, the real mystery was just beginning. Were we seeing a coincidence or a brand new class of explosions? As we dig deeper into the data from AT2025ULZ, it's becoming clear that we might need a bigger dictionary. The term superkilonova isn't actually new. It was originally coined to describe a massive spinning star collapsing into a black hole and churning out a staggering amount of gold. We're talking several solar masses worth here. But Kalawasi and her team are now proposing a much broader and perhaps more exciting definition. They see the superkilonova as a hybrid event, a core collapse supernova that actually hides a kilonova-like merger inside its own blast. The team is the first to admit that this is still a developing story. Because of the massive distance and the overlapping signals, some still wonder if this was just a chance coincidence between two unrelated events. But if they're right, the implications are massive. It would explain where those featherweight neutron stars come from and provide a new factory for the universe's heaviest elements. As Kowalski in the study noted, future kilonova might not look like the perfect 2017 event. They might be masquerading as a supernova. We're now looking to the next generation tech, basically like NASA's Nancy Roman Space Telescope, estimated to come out in 2027, which is designed to pick up these type of explosions to catch more of these hybrids in the act. For now, we wait for more modeling and late-time observations to see if we've truly found a new class of cosmic explosion. It's a great reminder that in astronomy, there's always something new to see if you know where to look, and that the universe, it's going to continue to throw us curveballs and challenge what we know and make us expand our knowledge. That's a wonderful thing about the science of astronomy. It's a wonderful thing about the hobby of astronomy and studying the things that are going out there. Hope you found this interesting. Would love feedback if you find something different than what I came up with. I'll put some links to the sites that I used for this in the bottom of the post here. Hope you have clear skies. We had a beautiful night tonight, but the moon is so bright. Should hopefully have a couple good nights in a row. I'm hoping to get out one night this week. I have an appointment to do some outreach, and then one night I just need to get some open cluster work done. So anyway, I hope you have clear skies. We'll catch you later, and take care till then.